It's now my pleasure to introduce Dr. Peter Victor. Dr. Victor has worked for nearly 50 years in Canada and abroad on economy and environment as an academic, consultant, and public servant. Dr. Victor was the founding president of the Canadian Society of Ecological Economics and a past president of the Royal Canadian Institute for the Advancement of Science. Prior to becoming Dean of the Faculty of Environmental Studies at York University in 1996, he was Assistant Deputy Minister for the Environmental Science and Standards Division in the Ontario Ministry of the Environment. Currently, he is Chair of Ontario's Greenbelt Council, a member of the board of the David Suzuki Foundation, and the Centre for the Advancement of a Steady State Economy, as well as belonging to several advisory boards in the public and private sectors. Dr. Victor's work on ecological economics has been recognized through the award of the Molson Prize in the Social Sciences by the Canada Council for the Arts in 2011, the Boulding Memorial Prize for the International Society for Ecological Economics in 2014, and his election to the Royal Society of Canada in 2015. Today he'll be speaking about ecological economics and global change. I should note also that this afternoon, as Dr. Arya mentioned, you can explore this topic with Dr. Victor in greater depth in a workshop that he's leading called Exploring Alternative Economic Futures. Please join me now in welcoming Dr. Victor.
Well, good morning, everyone, and lovely to be here. Thank you for the invitation to participate in your conference. It's quite interesting to be on a panel not knowing anything about the other speakers and what they're going to say, but as I listened to the two who preceded me, I realized that what we're laying before you was a very moving story about an individual to a very alarming set of events about communities, and I'm going to go, if you like, to the next level to talk about global change and how I think about some of this as an ecological economist. So let me begin by giving you a very quick understanding of what ecological economics is about. If any of you have ever taken a course in economics or opened up an introductory textbook in economics, you'd have seen a picture something like this describing what an economy it looks like. It's an interaction between firms and households, with firms selling goods and services to households in exchange for money, households providing land, labor, and capital, which they're the ultimate owners, in return for payment. And we talk in economics terms about this economic cycle. The problem for somebody like myself who's interested in the interaction between the economy and the environment is there's no environment in this picture. And that gives rise, I think, to the misconception that this economic cycle can go bigger or go faster, however you want to describe it, but can keep producing more and more goods and services without limit. So as an ecological economist, I add in, and others who do this work with me, some of the missing parts. So in order to sustain that economic cycle, we know that we need continual input of materials and energy from the biosphere. It's signified by the arrows in the lower part of the diagram. We also know from some fundamental physical laws that all of the material and energy that we bring into the economy is ultimately disposed of as waste back into the biosphere. And we can run into problems there because we overload the capacity of the biosphere to accept the wastes we produce. That then begins to interfere with the biophysical cycles, which feed back and affect the capacity of the biosphere to provide us with food and water and so on. And all this is taking place on planet Earth. So the ecological economics perspective of an economy is given in a way by this graphic here, with the economy as economists understand it in the center, doing what it does, but fundamentally dependent on the biosphere to keep going and to keep expanding. So one of the key questions we're more and more interested in now is whether it's possible to expand the output of the economy, the goods and services that we all consume, at the same time as reducing the burden that the economy is placing on the biosphere. And this gives rise to the terminology that's becoming more and more current, is decoupling. Can we decouple the economy from the biosphere? Well, I'm going to pick just one example to show that this may be more difficult than we're being led to believe. Let me just explain a little bit more detail what decoupling would look like. So this is a graph of time, and here's economic growth with the gross domestic product rising steadily. Gross domestic product is just a measure of the dollar value of the goods and services consumed in an economy, usually over a year. If we're going to decouple economic growth from resources, we would expect and we would require the resource input into the economy to decline in absolute terms at the same time that the economy is expanding. And we need a further kind of decoupling, and that is to separate the environmental impact of the resource use and disposal that this economic growth is requiring. Now, just a few weeks ago, if you followed this sort of literature, we found this following headline: decoupling of global emissions. They were referring to carbon dioxide and economic growth confirmed. This is the International Energy Association, and of course, this attracted my attention immediately. You know, what's going on? This could be extremely good news we need to pay attention to. What were they looking at? Well, this shows CO2 emissions from the energy sector over time, and you can see that from 2013 to 2014, they didn't really increase. Actually went up a little bit, but didn't really increase. The distinguishing feature of this apparent stabilization of emissions is that it didn't coincide with the decline in global output of goods and services, whereas you see some other little bumps previously, which were associated with a decline in economic output. So the IEA continued with its celebration. It said, "Uncork the champagne. IEA announcement of energy-related carbon emissions receives intense coverage," and it was covered worldwide. My question here is, are we celebrating too soon? So I'm going to look at this in a little bit of detail to suggest that we are and what the implications of this problem of lack of decoupling represent to us. Well, the first thing is that the IEA data is only for carbon dioxide. It's not for all greenhouse gas emissions. There are about 6 major greenhouse gas emissions. So they were only talking about 70% of the emissions that caused the problem we're concerned with. Plus, they were only looking at greenhouse gas emissions or carbon dioxide emissions from the energy sector. So they're only really talking about half of the greenhouse gas emissions generated annually, with no story at all to tell us about the others. What will we need, is the question I'm going to put to you now, to reduce greenhouse gas emissions by about 80% by mid-century? That's the sort of target that the nations of the world are thinking of, that we have to achieve in order to avoid an increase in the average global temperature of 2 degrees centigrade. Well, the point I like to make when we consider decoupling is that the rate at which you have to decouple to reach a target like that depends upon how fast the economy is growing. If the economy is growing very fast, then you've got to reduce the greenhouse gases per dollar of output much faster than if the economy is growing slowly. I have a little table here to illustrate this. So on the top, we have the annual rate of economic growth going from 0% up to 4%. And on the vertical axis, we have the annual reduction in greenhouse gas emissions per dollar of GDP. And I put those zeros in to show that if the economy is not growing and you're not reducing what we call greenhouse gas intensity, the greenhouse gas emissions per dollar of GDP, then greenhouse gas emissions just don't change. That stabilizes it. And the same is true, more or less, it's an approximation, but if the economy is growing at 1%, then you need to decouple at 1% in order to just remain stable. So what we just heard the International Energy Agency announce, that the global economy grew at about 3% over the 2 years I mentioned, and greenhouse gas emissions per dollar fell at about 3%, so it was stabilized. That's not going to get you an 80% reduction in emissions in, 34 years. This is what is required. If the economy doesn't grow at all, and we reduce greenhouse gas intensity at 5% a year, we'll get there. If we reduce it at 6% a year, we'll do better than 80% and so on. But if the economy grows at all, even at 1% a year, you can see that you need to reduce greenhouse gas emission intensity even faster. And if we keep this up, let's say that we carry on with our 3% growth that we had the years that the IEA was reporting on, we'd have to reduce greenhouse gas intensity by about 8% a year. Not 3%, 8%. Every year, year after year after year. It's completely unprecedented. And makes me feel somewhat pessimistic that we have a chance of doing it. And I'll say a bit more about that in a few minutes. I'm going to put these cells up as well, just to complete the story. This shows that even with some decoupling, indicated down on the left-hand column, if the rate of economic growth is faster than the rate of decoupling, then emissions keep rising. So don't get hooked on decoupling on its own. You've got to also look at economic growth rates. Thing about greenhouse gases and climate change is, though, we're not really dealing with a flow problem. It's not the flow of greenhouse gases each year that cause the problem. It's the accumulation of these greenhouse gases in the biosphere that cause a problem. It's what we call a stock problem, the stock of greenhouse gases in the atmosphere that causes the problem, not the annual flow. And when we look at the stock, it's a very disturbing picture. So this is the concentration of CO2 in the atmosphere going back to 1960, I believe, when these measurements on Hawaii were made. And you can see how they've risen steadily to 2015. If we add a further time dimension, though, we go back to the year, what is that? I can't even read my own graph here. Year 200. Well, you can see it's... Yeah, but, 1700, sorry. It's the 200, which is the CO2 concentration. You can see that this increase that we've seen is quite recent. If we take a longer time scale, we go back 10,000 years, you see that the CO2 concentration in the atmosphere on the planet was pretty much stable. And this increase we're talking about is very, very recent. And if you go back 800,000 years, you can see it's a completely anomalous phenomenon. Now, this particular graphic, which I came across just a few days ago, is a very effective way of showing what happens when you look at the way in which temperature change has happened from 1850 to 2016. Around the circumference, you can see months, and every point that goes on this graph is going to show the average temperature increase year by year, month by month. And you'll see how if the points stay within the circle, which is marked as 0, then the temperature is not increasing. And if we move out beyond that, then it does increase. So there you are, the years. Not much happening in the 19th century, gradually moving out. Now we're into the early part of the 20th century. Again, a little bit beyond. Now we pass 1950. Coming up to the end of the 20th century, you see this very rapid pushing outwards. The friend who sent this to me refers to it as the death spiral. That's a appropriate terminology for it. Anyway, question then I think we have to face is, can we transition away from our use of fossil fuels to get all the energy that our economy and our lives seem to depend upon? There was a very influential piece in the Scientific American which said that yes, we could get to total renewable energy by 2030, planet-wide. And lots of people like to refer to this because it's such good news. A much more thoughtful account, in my view, has been produced by Professor Vaclav Smil, who's emeritus at the University of Manitoba, and what he has analyzed is energy transitions that have taken place in the past, and basically says that it takes decades before any new form of energy, any source, even reaches 30% of the energy requirements of the system it's supporting. So we take decades, even a century, to transition energy, and yet we have to do it in 25, 30 years. It's a real dilemma, and it gets harder, in my view, the faster we want our economies to grow, because we have to do the energy decoupling and CO2 decoupling even faster. It's hard when I give this kind of talk not to be the bringer of bad news, but I don't seem to have much choice because that's almost all that I ever encounter. There's now reference to what we're calling the Great Acceleration. You see here these two trends, probably quite familiar to you, how world population increased rapidly, and then the global gross domestic product has increased rapidly, particularly since early to the mid-20th century from there onwards. But those trends are just part of a whole array of rapid increases, whether it's in forestry, agriculture, land conversion. We see this commonality of this increase in impact that the economy is having on the biosphere, and to match that, we see a similar set of trends when we start measuring the impact on the global Earth system. So you see various measures for CO2, I've talked about nitrogen oxide, methane, stratospheric ozone. It's just the list is very, very long. And so now people are talking about the era that we're in as the Anthropocene, the era in which humanity is having the leading impact on what's happening to the biosphere. All is not lost. Here are a couple of projects that I'm involved with. There are many more going on around the world, but I thought I'd just mention a couple. There's a center newly established for sustainable prosperity in Britain, which is looking at these issues in a very comprehensive way, not just the economics, of course, but the science, the philosophy, the ethics. It's a very good thing that I'm part of. I'm proud to be so. And there's the website for you to look up what we're doing. And then the other activity I'm involved with is trying to train a cadre of economists, PhD economists, equipping them to be effective in the economics of the Anthropocene, to get beyond that original graph I showed you of just thinking of an economy as an isolated, freestanding system, to one that's really totally embedded in the biosphere. I think the time has come, if it's not already passed, where we have to, as a society, make a serious choice between the direction that we wish to pursue. This graphic shows a rather elderly gentleman looking at economic growth or sustainable prosperity as the future, but the choice won't be made by people of my generation. It'll have to be made by the next generation, and I hope that we are doing the best we can to equip them to do it. So thank you very much for your attention, and I look forward to talking with you more later.